Hello and welcome to another video about set theory. This is going to be our second video where we take a moment and look at what we've learned so far and try to apply it to natural language and see what we can learn about natural language by using these sort of models. So the first place where we can use set operations with regard to natural language is basically in just sorting our ideas of what types of things fit into different categories, right? So if we have this idea that we have a set V that has all members, all verbs in it, and N that has all nouns in it, we can create a set L, which is the union of V and N, which is all the nouns and verbs that exist. Or we can create a set M, which is the intersection of verbs and nouns, which are all verbs that can be used as nouns and nouns that can be used as verbs, which is pretty extensive in English. So if we think, you can rope a cow, or you can go get some rope, right? And in one of those, rope is being used as a noun, and in one it's being used as a verb, right? So this is all the ones where it can be used as either a noun or a verb, unlike cat, which would be weird to use as a verb. I catted the other day. You could imagine it means behave like a cat or something like that, but it's a little bit weird, right? So it wouldn't be in this set. So this is the first thing that you can do, is basically sort through your ideas, but you can do this in basically any sort of scientific or any sort of thought-related field, right? Anything where you have to think about things and sort them into categories, you can use these sorts of operations to think about things and sort them into categories. But like in the last video, what we're going to do is talk a little bit more about the meanings of sentences and how we can treat the meaning of a sentence as being based in set theory. So in the last video, we talked about how Ravi dances means that Ravi is a member of the set of dancers. In this, we're going to look at sentences like this where you're assigning two properties to Ravi, right? So Ravi is a tall runner. So essentially you're saying that Ravi is tall and Ravi is a runner. Now we'll come back to these examples like this in a bit, because Ravi is a tall runner is different than saying Ravi is a tall giraffe, right? So the degree of tallness is going to differ. But for right now, we don't really care about how we assess the meaning of tall. All that matters is that we have a set of things that are the tall things, right? And all we're thinking about is, once we've assigned the word tall to Ravi, is Ravi in the set of things that can have the word tall assigned to them, right? So there's two different ways that we can express this in set theory. We might say that this means Ravi is a member of the set of tall things, and Ravi is a member of the set of runners, right? That gets you the right intuition, correct, right? So Ravi is both tall and a runner, right? So that's one way we can do it. But this is kind of, requires us to use this operator, which we haven't, done anything with what the heck does and mean in this context yet. We'll get to that when we talk about logic and stuff, but we haven't really talked about that yet. So we might like another way to express this. And now that we have the operation union, or the operation intersection, we can do this. So we can say that Ravi is a member of the set that is the set of tall things intersecting with the set of runners. Right? So we have the intersection of the set of tall things and the set of runners is what Ravi is a member of, right? So if we think of this as tall and runners, this is where Ravi falls, right, in the intersection. And this essentially, if we think of Ravi as a member of both of these sets, that's essentially just saying exactly the same thing as this, right? So this is a good way to deal with and conjunction. Next, we're going to talk about something called exclusive or. So the word or in English actually has two meanings, one of which is and, right, is just like and the other one is called exclusive or, which means one or the other, but not both, right? So we can use or either in the context, I'm going to go to the gym or go to work today, and it would be okay if you did both of those things, right? But you could also mean it to mean I'm going to choose one or the other. And what we're talking about with exclusive or is choose one. Right? You don't get to choose both of them. So what would the meaning of this be in terms of set theory, right? So essentially what we want to do, if we're constructing our nice little Venn diagram, is we have fast things and slow things, right? And we want either fast or slow, but not in the middle, right? Yes. So this is going to be interesting. We have to say that Ravi, I'm just going to abbreviate him as R, is a member of some set. And how do we want to describe this set? We could describe it as, fast, or he's a member of the set of fast things, and then just say or member of the set of slow things. But since we want to sort of define what or means, we can do this, right? The set composed of the set of fast minus the set of slow union the set of slow minus the set of fast. So why does that work, right? So if we take the difference between fast minus slow is right here, right? It's this side. That gets you this. And slow minus fast gets you this, right? And once you union those together, it's both of these areas. So Ravi is a member of these areas. Right? He can't be a member of the set of things that are both fast and slow, which would be hard to be a member of, but you can imagine, people who are fast and slow, depending on how much they ate this morning or something like that, right? So this is exclusive or, is we've basically defined how we do exclusive or. Isn't that wonderful? Right? So that's very interesting. Let's try this with something that has to be entered as a subset, right? So all cats are orange or black. We're using exclusive or here. Right? So we have, instead of doing membership, we have to do subsets again. Remember? Because we're talking about cats being a subset, right? So cat A is either orange or black. Cat B is either orange or black. Cat C is either orange or black, right? So we say that the set containing X, such that X is a cat, is a subset of the set composed of which is the union of F minus S and S minus F. Isn't that wonderful? We have this as the meaning of exclusive or, but it's interesting to see that this same phenomenon that we saw last time, which is that adding Ravi, saying that Ravi is tall, just makes him a member of the set, whereas all cats doesn't make all cats a member of the set. It makes it a subset of the set. So that still is there. We still have to investigate that as linguists, And this is a wonderful thing that set theory has given us, a wonderful insight into language. All right, so this has been our natural language aside for set operations. I hope you have enjoyed.